Hello, thank you all for joining us. I'm Matt Hubeck, the moderator for today's webinar. If during the webinar you have any viewing difficulties, hit F5 on your Windows keyboard or Command R on your Mac to refresh the webinar window. For volume control, keep in mind you may need to adjust your Windows volume and/or computer speakers to hear the webinar. Also, at any time during the webinar, please feel free to submit questions. After the presentation, we will address your questions in a Q&A session. With that, I'll turn things over to Jason so we can get started.
Great, thanks, Matt. First of all, I would like to welcome everyone and thank you for joining us for BioTek's educational webinar, Maximizing Microplate Washer Performance to Develop Robust and Reproducible Assays. We have nearly 500 registrants today from 49 countries around the world, so thank you again for taking time out of your day. BioTek offers a complete line of microplate instrumentation that includes microplate washers, dispensers and pipetting systems, multi-detection readers, and automated plate stackers to automate any or all of those individual components. However, today we're focusing on the presentation of proven recommendations for aspirate and dispense settings across multiple applications for dependable wash performance, along with the importance of proper instrument maintenance. In terms of our plate washers, we offer 3 levels of plate washing automation. First of which is the ELX50 as an automated strip washer, the ELX405 as a full plate washer, and the EL406 as a full plate combination washer dispenser. Any of these products are suitable for automating the wash steps of magnetic and polystyrene bead-based assays, such as those developed on the Luminex XMAP platform. Newly available models of all 3 make these products suitable for both the automation of 96 and 384 well assays. Custom magnets in either flat or ring designs each incorporate high-energy neodymium iron-boron magnets for the rapid separation of micrometer and nanometer beads with superior retention. Along with biomagnetic separation, fast and efficient vacuum filtration modules with user-selectable vacuum levels offer accommodation of a full range of filter pore sizes from 0.45 to 1.2 micron. Along with bead technologies, any of the washer products are suitable for standard ELISA and cell-based assay wash requirements, making these products 4-in-1 solutions for automated microplate washing. The first wash assay technology in which we'll talk about the optimization of wash parameters is ELISA. Historically, the most common assay technology for which microplate washers have been utilized for many years. There are several techniques for detecting different parameters. However, the essential ELISA building blocks remain the same. With that, you have the solid phase being a microplate. Let's say it's pre-coated with antibody. Unknown samples are added to that containing antigen, followed by a small incubation. The immune complexes are allowed to form. An important wash step is then added to remove any unbound protein. That wash step is followed by an enzyme conjugate addition, again with an incubation. That enzyme conjugate is specific for the immune complex. Another important wash step process follows that to remove any unbound conjugate, and finally a substrate addition, resulting in color development. The color development is designed to be directly proportional to the amount of analyte in the sample. Therefore, quality wash steps make these assays successful. The first factor affecting ELISA plate washing is often the wash solution composition. The typical wash buffer is a PBS solution incorporating some sort of detergent to aid in the removal of loosely bound protein. The next factor affecting ELISAs are the dispense parameters and the dispense process. It is very important that equal volumes be sent to all wells of the microplate. This amount should be optimized and enough to cover the surface area coated in the well, including the sides. It is important to provide equal dispense force to each of the wells of the plate. In terms of dispense rates, a gentle dispense rate is often useful. And this is important because it removes free protein without stripping anything bound within the immune complex. Keep in mind, for some assays, some more tenacious assays, higher flow rates are often used depending upon the application. Also, the wash cycle number is determined experimentally. It is often found that less than 3 cycles leaves residual unbound material. Together with the wash buffer composition and the dispense parameters, the aspiration parameters of the wash process are often the major cause of precision problems when inappropriately programmed. There are a few specific aspiration parameters that need to be optimized, the first of which is the aspiration tube location. With flat bottom plates, aspiration tubes want to be towards the side of the well, and that is because in a flat bottom plate, liquid accumulates around the outer rim. In round bottom plates, the aspiration tube is ideally in the center of the well. Regardless of the plate type, the tube should never touch the bottom of an ELISA plate well. With automated plate washers, keep in mind a top-down aspiration. With this, keep in mind that as soon as the tube is touching the liquid, the aspiration is enabled. Vacuum pressure, very important. You want sufficient vacuum pressure to effectively remove all the fluid, even during overfill dispensing. However, you do not want so much vacuum that air is drawn across the absorbed protein coating. High vacuum pressures may result in shear stress. Fluid residual should be minimized in all cases with an ELISA assay. Also note, it is important to stop aspirating as soon as the fluid has been removed from the well. You want to avoid completely drying out a well. This can lead to protein denaturation. And finally, soaking and shake steps may be used to improve removal of non-specific bound material in the microplate well. Now let's look at some specific wash recommendations, as an example using a BioTek ELX 405 full plate washer with one of the more common plate types, a 96 well flat bottom plate. On the BioTek washers, a wash protocol is broken into 3 programming areas, first of which is your method and your method parameters. Within the method parameters, the first prompt is for the number of cycles. Most users wash 3 to 5 cycles in an ELISA. Soaking and shaking, as we said, most do not soak. However, if one chooses to soak, 5 to 30 seconds is sufficient. In terms of shaking, if one chooses to shake, 5 to 15 seconds at any intensity. Typically, if shaking will be enabled, the faster the better is recommended. Priming after soaking is an optional parameter, but it's generally not necessary. It's only necessary to reprime the washer if an extended soak has been incorporated into the assay wash steps, perhaps 5 to 10 minutes, which is usually not the case. If you are priming, you'll want to reprime the entire fluid path at a fairly high rate to remove any air in the line that may have accumulated. The next part of a wash process to be programmed are your dispense parameters. An average dispense volume for a 96 well plate is 300 to 375 microliters. If you're shaking, keep in mind splashing is potential. Therefore, you'll want to reduce the dispense volume to 200 to 250 microliters per well. Dispense flow rate on the BioTek washers, you have up to 10 flow rates available. Typically a 3 to 5 is recommended. For assays requiring more intense washing, you can incorporate a higher rate, perhaps 7 to 9. In terms of dispense height, 120 is the default on the BioTek ELX 405. For most SBS plate heights, 114 to 116 is recommended plate height. Horizontal dispense position, the default is 0, which is the middle of the well on the 405. It's often recommended to offset towards the left side of the well, -10 to -30, depending upon the plate type and the other parameters recommended. And lastly, bottom washing. Bottom washing is normally not used. If bottom washing is enabled, and this can be useful for those hard-to-wash, sticky assays, this is designed to be done. It's an additional wash cycle along with those that have formerly been programmed. And if you're incorporating bottom washing, you're going to want to dispense towards the well bottom, perhaps with a dispense height of 50, so close to the bottom of the well but not at the wall, with a dispense volume similar to that which was already programmed at a fairly high dispense rate. In terms of your aspiration, again, as we said up front, the aspiration parameters are very, very important, and it's often the misprogramming of these parameters that lead to assay failure due to the wash process. The first of which is your aspirate height. The default on the BioTek washer, you'll want to optimize that for your plate type. We recommend 27 to 28, perhaps as high as 34, depending upon the plate. Horizontal aspirate position is very important. We recommend a horizontal aspirate position of -25 to -30. That will position your aspiration tubes on the ELX405 towards the left-hand side of the well, 1 to 1.5 millimeters from the actual side. The aspirate rate is normally 3 to 5. 5 can be useful as a higher rate when using buffers without surfactant to break surface tension. Aspirate delay is not often used, but if it is, 500 milliseconds is sufficient. Very important in the aspiration parameters are your crosswise aspiration. 1 out of every 2 users incorporates crosswise aspiration in a flat bottom plate wash, and that is because a crosswise aspiration will fully aspirate the ring of residual, leaving a dry well with 1 to 2 microliters maximum behind. In final aspiration, you do want to enable final aspiration on the washers. While some users bring their plates out full, most want a dry well. Leaving ELISA, the next assay technology type we'll discuss are bead technologies, one of which is the Luminex technology, the Luminex XMAP. Luminex XMAP technology is a microsphere bead-based assay technology thought to offer increased efficiency over ELISA, whereas with ELISA you're often looking at 1 analyte per well. With the Luminex technology, you can analyze up to 500 analytes per well. XMAP incorporates dye-impregnated beads. These beads are then conjugated with biologicals, perhaps antibody or nucleic acid, providing analyte specificity. Each of these beads capture a specific analyte. Each bead type captures a different analyte. Like in ELISA, very important to remove unbound material. This can be done either through vacuum filtration or biomagnetic separation. We mentioned up to 500 analytes per well can be measured. That will vary, of course, based upon the Luminex reader. 3 readers from Luminex are available today. The MagPix is the newest reader, can process up to 50 analytes per well. That reads 96 well plates and processes magnetic beads. The Luminex LX100-200 will read both magnetic and polystyrene beads, up to 200 analytes per well, 96 well plates again. And finally, the FlexMap 3D is the Luminex reader that can read up to 500 analytes per well, depending upon the panel that is offered, and in both 96 and 384 well plates. There are 2 bead types we've referred to here, the first of which is the Microplacas. This is the original polystyrene Luminex bead, 5.6 microns in diameter. This can be washed through vacuum filtration only. The next generation Luminex bead are the Magplex beads. These are polystyrene beads with a superparamagnetic coating, 2 to 4% iron, resulting in a slightly larger 6.5 micron bead. Along with vacuum filtration washing, these are also processed through biomagnetic separation, offering benefits such as improved CVs and more unattended operation. All of the BioTek washers are Luminex XMAP approved. We're going to look at 3 examples of Luminex XMAP type assays, both magnetic and polystyrene, some of the workflow processes, and the important parameters when programming each of these. The first of which is a magnetic bead panel. This is a Millipore human metabolic hormone panel. This is an antibody-based analyte capture assay using specific analytes to capture human peptide hormones onto magnetic beads. With a series of wash steps, removing unbound material, and reagent additions, specific metabolic hormones are quantified by fluorescent signal. This is a 13-plex panel you're seeing here, And there are different color-coded beads for each hormone, allowing this to be run on single samples. When a comparison was performed through biomagnetic separation washing using the ELX 405 washer, another off-the-shelf washer, and a manual vacuum filtration process, the results indicate similar standard curves. However, the automated plate washers, including the 405, produced higher precision and not as prone to high variance data, showing a reduced loss of beads by filter plate clogging, one of the primary issues with the polystyrene bead and vacuum filtration, and one of the benefits of moving to magnetic beads. On that note, BioTek offers a collection of magnets in both 96 and 384 well formats. Here you're seeing both our 96 well format flat and ring, along with our 384 flat and ring. BioTek's flat magnet designs are customized exclusively for BioTek by Dexter Magnet Technologies. On display here is the 96 well format. You can see the beads are immobilized in a band at the bottom of the well. This would be a flat bottom well in this image here. The beads are immobilized in an east to west pattern. If this was a 384 well, you would see the same band but running north-south versus east-west. As an alternative to a flat style magnet, although still high in strength, BioTek offers ring magnet designs. These are designed exclusively for BioTek by VMP Scientific, and they immobilize the beads in a 4-zone ring. The one benefit of the ring is that less residual can be left behind in the well. With the flat bottom, in a flat bottom plate with the flat magnet, it is necessary to leave some residual in the well to protect those beads. That is an added advantage of the ring style magnet in that that same residual need not be left behind. General biomagnetic separation recommendations with the bead technologies. Number 1, aspiration most critical. Now, having seen the immobilization patterns of the different BioTek magnet styles, you can see where the location of the aspiration tubes relative to the beads is very important. Keep in mind those beads are only marginally attached, so where you put the tubes is important in bead retention. Also, the duration of the beads, the duration of their exposure to the aspiration process. When fluid is aspirated from the well, localized vortexes are formed which can scour the beads away from the magnet. It's been proven with an automated plate washer that rapid aspiration dive rates clearly work best in reducing the exposure to the beads, improving the bead recovery at the end of the process. And finally, depending upon the plate type and the magnet arrangement, such as those you've seen here in the BioTek collection, different software offsets will be required. This first example, we were looking at the Millipore MagBead human metabolic hormone panel. You're seeing an experiment in which the different parameters were tested with the resulting bead recovery. And what you're seeing is on the left-hand side of the slide, the original number of beads, and then after 2, 4, and 6 washes. And what is evident is that even after 6 washes with an optimized set of parameters, nearly all of the beads are recovered. And this assay was validated with these key wash parameters being found to be the most important. And number 1 is a pre-soak. After the beads are added and the sample is added to the well, it is important to enable a pre-soak to allow the beads to immobilize at the bottom of the well. A 60-second pre-soak was found to be helpful. 3 wash cycles were decided upon with 60 seconds in between each of those, again to allow the beads to re-immobilize onto the bottom of the well, onto the magnet. In terms of the dispense portion of the wash protocol, a 200 microliter volume at a medium flow rate 5, and at a dispense height of 130. In terms of the aspiration, an aspiration height of 35 was found to give the best bead recovery at BioTek's fastest rate. A flow rate 6 is our fastest rate, which drops the tubes in and out of the well as quickly as possible. This aspiration height of 35 was found to be useful because Millipore chose the flat magnet style from BioTek in which some residual must be left in the well. The next example, another example of an XMAP-based mag bead assay, is a Luminex avian antibody test. This test is designed to detect the presence of specific antibodies in bird serum. It is a 2-plex assay, and looking at this workflow, you can see several wash steps. There are actually 3 wash steps of 2 cycles each, 60-second soaks, 150 microliter dispense volumes were decided upon before the final streptovide and conjugated phycoerythrin detection reagent being added and processed on the Luminex reader. Looking at some of the results, here we're seeing a comparison of a manual wash process with a handheld magnet compared to an automated biomagnetic separation process on the BioTek ELX 405. Looking at a few samples, it is evident that comparative signal is being returned with the added advantage of unattended operation. 2 different 2-plex assays were run, the first on 8 wells, the second on 16 wells. On the next slide, we're looking at an average of all 24 wells and comparing acquisition times. At the beginning of the workflow, 1,000 of each bead type were added to the wells. 120 beads per well were counted, 60 beads of each type. And what we're seeing are the acquisition times. The more beads present, the faster the acquisition time. This data is indicating that the ELX 405 automated washer retains more beads than a manual mag separation process. And the third bead example we're looking at here today in the presentation is a polystyrene bead-based assay. So contrary to biomag separation, this is a TSH assay incorporating the original Luminex polystyrene bead. These must be processed through vacuum filtration. Here in the workflow, this was automated with a BioTek ELX 50 strip washer, and the washer was used to provide a combination of automated steps: reagent addition, shaking, and aspiration several times over before being finally read on the Luminex reader. On this slide, we're looking at a comparison of the automated process on the BioTek ELX 50 to an automated vacuum manifold. And the data that's reported indicates similar median signal with less well-to-well variability, better CVs between the replicates when incorporating the BioTek ELX 50 washer. Both the ELX 50 and the manual wash manifold provide responses correlating to concentration, but again, less variability with the ELX 50. In terms of vacuum filtration recommendations with Luminex bead type assays, you'll want to keep in mind a couple of key parameters. Number 1, filtration time, and number 2, vacuum levels. These should be optimized so that the wells are fully aspirated but not subjected to vacuum for prolonged periods of time. And that is because it is very easy to over-aspirate and aspirate the beads down into the filter of the filter bottom plate. It will then often not be necessary to get those beads resuspended in the well for recovery. With BioTek's vacuum filtration modules on any of our 3 washers, sample preparation steps typically require a very short filtration time. 3 to 5 seconds is recommended to start with a low to medium vacuum setting for well evacuation. Depending upon the sample type, if it's more viscous, you may need to aspirate for longer periods of time at a higher setting, but certainly it is recommended to start with a shorter period of time at a lower vacuum. You will always want to avoid low dispense height settings. The defaults onboard the BioTek washers work. In all cases, it is possible to lower the dispense position to the well, but keep in mind when you do that, the aspiration, the top aspiration, is also coming along with that and does introduce the capability of aspirating beads from the top, therefore resulting in lower recovery at the end of the process. Moving on to cell-based assays and automating the wash steps of these assays on the BioTek washers. Cell-based assays can be automated with an automatic plate washer in a variety of different process types, including media exchanges, staining such as cell fixation, antibody addition and removal, fluorescent dye loading, and transfection reactions. With any of these, there are a couple of issues to keep in mind when moving a cell-based assay to an automated platform like the BioTek ELX50, 405, or 406. Number one is sterility. Number two is cell attachment. And lastly, like in the ELISA and in the bead technology washing optimization, you'll want to think about your dispense and aspiration parameters. Very important in providing a successful wash. Why are some cell assays tricky to wash? If we look at this slide, you can see this example cell layer on the bottom of the well. With some assays, these layers are not chemically bound to the well, considered loosely adherent. Strong dispense rates can cause holes to be formed in that layer and those cells to be aspirated. Using low flow rates possible on the BioTek washers, the fluid delivery can be much gentler, therefore providing a thorough wash, yet a gentle wash to these loosely adherent cell layers, leaving the layer intact. To provide a design perspective of these low flow rates, here we're seeing on board the ELX405 Select CW or the EL406 when standard flow rates are selected. So fluid comes in through the pump, through a fluid flow sensor, and when you're using any of BioTek's standard rates, that fluid is allowed to flow through the standard flow line or through a low flow line out to the manifold and into the microplate. When our optimized low flow rates are selected, what happens, that fluid comes into the washer through its fluid path. However, the flow control valve of the normal flow line closes, and that fluid is forced to flow only through the low flow line, through the dispense valve to the manifold and into the microplate, therefore producing a gentle drip to that cell monolayer. Here's a visual example of cells washed with standard rates and with a low flow rate. These are HEK 293 cells before and after a wash, clearly with some damage, seen as a result of a dispense rate that was too high for this loosely adherent cell layer. On the right-hand side of the screen, we're seeing these same cells washed before and after with a low flow rate. Clearly evident, no damage. BioTek does this in addition to the unique fluid path, also by the way in which our manifold is designed, our patented dual-action manifold. Here you're seeing our dual-action manifold in its dispense position and aspiration position. It's a two-piece manifold, therefore separate aspiration and dispense parameters are able to be programmed, but both of those two manifolds work together to process the plate. Just recently, we've introduced improved cell washing, in which we've increased our dispense tube angle from 7 degrees to 20 degrees, offering even more gentle performance on those loosely adherent bound cell monolayers. For all of you with BioTek washers in the field from years past, ELX 405s and 406, know that this new 20-degree manifold is absolutely something that can be upgraded. At the end of the presentation will be a link to our customer care group, and getting in touch with our local service center, we can arrange for those upgrades to be offered to you. In terms of general cell-based assay wash dispense recommendations, if possible, you want to use the highest rate. There are many cell lines that are adherent and can handle higher flow rates. However, if they can't, if you clearly see some disturbance to your cell layer, you're able to use our two low-flow cell wash rates available on the Select CW or the 406. Regardless of the rate, you can always incorporate our offset dispense tubes, part of our dual-action design, to direct that fluid stream at the side of the well. Along with your dispense parameters, your aspiration parameters, very important. Here are some general aspirate recommendations. With a cell-based assay, you will always want to leave residual. This residual fluid in the well acts as a shield to prevent trauma to the cells. It maintains cell hydration. If possible, in a 96-well assay, we recommend leaving 75 to 100 microliters per well. In a 384-well plate, we recommend leaving 20 to 30 microliters per well. In terms of your aspiration rate, similar to as we mentioned with the bead technologies, you'll always want to use a faster aspiration rate or travel rate, however it's called, on the automated plate washer. This will provide the least disturbance. This is very different from an ELISA where you'll typically want to aspirate at a lower rate to provide more accuracy and precision in the aspiration. With a bead technology or a cell-based assay, getting in and out of the well as quickly as possible is found to be optimal. Also different than an ELISA, with a cell-based assay, you will always want to avoid aspiration delays. An aspiration delay is dropping the aspiration tube to the bottom of the well and pausing for a period of time. This, in a cell-based assay, will cause turbulence, which can clearly lead to monolayer damage. Something else to keep in mind when using a lower dispense rate, for example, some of the low flow rates on the automated washers from BioTek. These low flow rates can enable dripping out of the dispense tube to provide gentle dispensing to the cells. Keep in mind, when you're using a low flow rate, your aspiration tube, which is also present at the well, is typically always on and in an aspiration mode. As the fluid is coming out of those tubes in drops, it's very easy to aspirate those drops up the aspiration tube without enabling the fluid to reach the cell layer. We have an optional feature on the washers called vacuum on volume. It is definitely recommended when using a low flow rate to also utilize the vacuum on volume and set this equal to your dispense volume. This will guarantee the droplets make their way to the cell layer before being aspirated. Along with 96 cell-based assays, it is very possible on the BioTek washers to automate 384 cell-based assay washing. Similarly to 96, with a standard dispense rate, it is easy to damage cell layers with a standard flow rate. Here on this slide, you're seeing a 2x and a 4x view of cells before and after wash with a standard rate with damage present. On the right-hand side of the screen, you're seeing these same cells washed with one of the BioTek low flow rates before and after the wash with no damage resulting. When washing 384 well plates, for example, in a cell-based assay, you will want to keep in mind a potential issue in which it's easy to form a plug in the well. This is somewhat a function of the buffer properties, for example, using new dry plates or buffers without surfactants. And what can happen when you use a standard dispense position at the center of the well, the fluid comes out when using a low flow rate, and causes an air pocket to form inside the well. This can result in flooding if a vacuum on volume is enabled. There is, however, an easy way around this. On the next slide, you're seeing droplet dissipation, and this is an easy way to get around that issue while still using the low flow rates to process 384 well formats. And you have a few choices, one of which is to offset the dispense tube from center. So rather than using the standard 0 dispense position, offsetting that aspiration tube and dispense tube towards the side of the well prevents that plug from forming and the fluid to make its way to the bottom of the well. Low flow rates, therefore, can be used in both 96 and 384 plate formats. In summary, on a BioTek plate washer, cell-based assay, 96 well plate, if you're using our new 20-degree angled manifold, you'll want to enable our CW Plus feature with the default 100 millisecond value. That will ensure all wells are dispensed and then dropping the rate to the normal low flow 1 or 2 setting. You'll want to incorporate our vacuum on volume, enabling the fluid to make its way to the bottom of the wells. And in terms of your dispense steps, our default dispense height of 120 can be used. However, our horizontal positions, you will want to offset those tubes in the well to prevent some of the issues we discussed. In terms of aspiration, we recommend our highest aspiration rate or travel rate of rate 6. And in terms of the positioning, a two-step aspiration can often be helpful. And in this example, you're seeing this two-step aspiration programmed as a one-step low aspiration in the well with the tubes oriented to one side horizontally, and a secondary aspiration a bit higher in the well with the tubes oriented in the X offset to the other side of the well. These parameters will leave 40 microliters of residual in the well to protect that monolayer. Along with assay parameter optimization, instrument maintenance is very, very important. Regardless of whether it be an automated strip washer or an automated plate washer from BioTek or someone else, regular maintenance will make the difference to continued performance. Things such as a day rinse, keeping the tubes wetted, periodically decontaminating the washer. All of this will keep your washer in top condition, and it can all be automated through the BioTek instruments, either from the keypad or from our optional liquid handling control PC software. One thing that has found to make even more of a difference is BioTek's built-in ultrasonic cleaner. We have an optional feature called Ultrasonic Advantage on the ELX405 and the EL406. It is a patented design, and it's programmed to execute user-specified cleaning for specified durations with selectable source fluids for totally unattended washer manifold maintenance. Ultrasonic Advantage, like a benchtop ultrasonic cleaner, depends upon cavitation. Cavitation is the rapid formation and the violent collapse of minute vacuum bubbles in a cleaning fluid. And it's the production of these bubbles and they're imploding on the washer manifold tubes that result in unattended operation. There are three essential components of any ultrasonic cleaning system. There's a reservoir containing your cleaning fluid, a power supply generating those cavitation bubbles, and a flow transducer converting electrical signal to high-frequency mechanical energy. With the BioTek ELX405 and 406 built-in ultrasonic cleaner, the user chooses a cleaning time, a cleaning fluid, and walks away to do something more important in the lab while the washer is cleaning its manifold in an unattended nature, resolving any protein and salt crystal buildup, and leaving the washer free for the next wash process to be executed. This can be done in an automated process or at the end of the day. The washer will automatically prime itself with cleaning fluid, clean per a custom protocol, flush and prime the system with rinse fluid or wash buffer, and ready for the next microplate washer run. Benefits to the lab of a built-in ultrasonic cleaner include reduced assay failure, a compact built-in design requiring no extra benchtop space, cleaning the toughest protein and salt crystal buildup, providing unattended operation, and restoring a 405 or 406's performance back to factory specifications when it left BioTek. In terms of recommended maintenance solutions, we can recommend deionized water with some surfactants such as Tween to break down surface tension in the manifold, or an off-the-shelf product such as Turgezyme, which as an added advantage also contains a protease enzyme that will also break down additional residual in those manifold tubes. In summary, BioTek provides 3 automated plate washing solutions, which can all automate wash processes of ELISA, cell-based assay, and bead technologies. The ELX50 is a high-performance automated strip washer incorporating a microprocessor-controlled syringe pump, delivering exceedingly precise and accurate wash results. This is a welcome upgrade from manual processing, and this will accommodate 96 and 384 well plate washing in a strip format. As a level 2 automated solution, the ELX405 is a full plate washer, easily programmed through its onboard interface or through optional liquid handling control PC software. The ELX405, as a step up from the ELX50, is robotic system compatible. Commercially available drivers can be purchased from a variety of off-the-shelf pick-and-place robots. And finally, as a level 3 solution, is the EL406 as a combination washer dispenser. The EL406 offers all the attributes of an ELX405 with the added advantage of reagent addition. From 1 to 3 independent reagents can be added along with the microplate being washed. The 406 conserves precious benchtop or robotic system space compared to a separate washer and 3 dispensers. It offers dispense volumes from 1 microliter, and this product automates the washing and dispensing to both 96-384 along with 1536 well plates. I thank you for your time, and we'll now take a look at the questions that have been posted. Okay, there are a few questions. Mainly these are having to do with the sound and the display of the screens. Some of these have been resolved at this point.
Jason, go ahead and click on the inbox there, and you'll see the most current questions.
Thank you, Matt. Okay. First question was, what is the rationale behind the increase in dispense angle? That is a good question. So BioTek incorporated a 7-degree angle in our dual action manifold designs for a number of years, and what we found was an increased angle would enable us to direct that fluid stream even more towards the side of the well to even offering that much better, meaning thorough yet gentle cell washing. So we have now offer both angles. We offer on our ELX405 Select, we offer still the 7-degree angle, but on those washers in which are optimized for cell washing, we call that our Select CW, those now come standard with a 20-degree angle. So again, it was seen as an improved design and as something that is available as an upgrade for any of our Select CW users in the field. The next question, does BioTek provide a fully automated ELISA workstation? Well, that is also a good question. We offer a number of products to automate different parts of the process. We offer these plate washers we've talked about today, and we offer bulk reagent dispensers. We also offer a pipetting system. We do not offer a single system that integrates all of that together. However, with some off-the-shelf third-party robotic systems, you can integrate all of the BioTek components, including our plate readers, to create an automated ELISA workstation. Here's another question. For magnetic beads, is it best to use the CW settings when picking speeds? The recommended settings for bead washing will be very similar to those we recommend when washing cells, in that you will want to incorporate kind of moderate dispense rates, very fast aspiration rates, getting in and out of those wells as quickly as possible. So there clearly are some similarities. I should also point you to the tech resources area of biotek.com, in which we have a number of more than a dozen different application notes and scientific posters now documenting proven performance for mag bead washing. And in each of those there are a selection of recommended parameters, so I would direct you there for that. Is there a pause step between dispense and aspiration in the wash cycles with mag beads? If so, how long? Very good question. Yes, there is a pause step, and users have found anywhere from 30 to 60 seconds to provide sufficient immobilization of the beads and preparation for the next dispense. What does prime mean? Priming of the washer. So priming is a term we use to prepare the washer for a wash process. So depending upon which plate washer you're using, if it's a BioTek or not, there's a certain amount of fluid to fill the lines and reduce the amount of air in those lines to less than 5%. In each of those conditions, whether it be a BioTek or not, we recommend a minimum prime volume to enable the lines to be prepped and ready for wash, or when changing reagents to ensure 95% purity. So that is what we mean by a prime volume. What is the optimal height for dispensing into a flat bottom plate? As a rule, for a flat bottom plate, in terms of the dispense position, that is relative to the height of the plate. So a standard ANSI SBS conforming plate is about 15 millimeters high. For that plate height, we recommend anywhere from 114 to 116 on the BioTek washers. In terms of the aspiration height, and that may have been what this person was asking about, that there, if you refer to my earlier slide, we'll want to typically set that somewhere around 27 or 28 to enable complete evacuation while not hitting the bottom of those wells. Next question is, how is the flow rate adjusted? On all of the BioTek washers, it's all software controlled. Depending upon the washer and the model of each, you have a number of flow rates available. And I gave some specific recommendations to some of those rates, and that is something that's chosen as part of your protocol. Can be from any number of rates from 1 through 11 on the BioTek washer. The higher the number, typically the faster the dispense flow rate. And with each of those, when they're selected on our onboard user interfaces, there is always a rate reported to you, so you can be certain you're choosing a rate appropriate for the assay. And the last question I'm seeing, what is an optimal dispense rate? It really depends upon the assay technology and the sample conditions and the kit manufacturer or the and their specific recommendations as well. They will infer to the the difficulty in washing a specific assay or not. So it would be important to refer to their recommendations. And I believe those are all the questions today. If there are any I've missed, we will certainly prepare a response to those and make that available to all of you who've attended today. Thank you for your time, and I will turn that back over to Matt.
Okay, thanks, Jason. We're going to wrap things up. I do see a couple more questions have come in. We'll get back to you on those individually. Sorry we couldn't answer all of your questions during the session, but we are running short on time. Thanks for joining us. The presentation slides are available via PDF download at the bottom of your audience view. And be sure to check out our website and blog, like us on Facebook, and follow us on Twitter to hear more about BioTek webinars or learn more about our products and how they can help you with your research. Thank you very much for joining us today.